at talking about the kind of the data center to market and timber and long spans as well, and in comparison to the steelwork side.
Yeah, exactly. We're starting to see more and more of those come through. A lot of that's being driven more from the client side in terms of they're wanting to use them. So it's becoming more of an opportunity for the industry. In terms of the structural design of that and how we can achieve them, there's always going to be limitations. So you can say a logistics hall, but again, how wide's a logistics hall, right? How long's a piece of string? So it's all project specific, but usually there is an opportunity for the use of timber through large trusses. So with a logistics hall, typically you get the height in the space to enable the depth of a truss system. So it's just working with the architectural team to work out, do you have the depth and the space to actually enable having a truss system that's appropriate? And then of course, there's always the question of commercial cost, between the two and what's the most efficient. And it's always a question of priorities, what's available, what's the design brief. But essentially you can achieve them with timber. You'll see them a lot. You'll see a lot of stadiums, especially in Europe, a lot of ice hockey halls or ice hockey rinks. There's some incredible buildings out there, and I definitely recommend people to look into them. Just simply search timber ice hockey rinks in Switzerland, for example, and you will see some large span timber trusses covering those spaces. Think of swimming pools, sports centres. There's a lot more available these days in continental Europe in comparison to the UK for those, because they're just again, they're close to the timber industry, so they've developed it a lot more. We moved a lot to brickwork historically and masonry for our own cultural reasons in the past, and now we're starting to see that movement back again towards timber.
Awesome. Just going into things a bit more technically, I will be honest with you, I don't understand any of this question at all. It was a question that we've had through, but someone was saying for my dissertation, I enhanced the strength of timber using BFRP rods, but I face challenges with fire resistance, particularly when using epoxy resin. What are your thoughts on this?
Getting straight into some technical things. To be honest, a lot more context potentially will be needed. Exactly where and how they're reinforcing their timber element. I imagine it's a beam that they're reinforcing. The question is, are they using that in a connection? So they're doing reinforcing rods around a connection. Is it because they've got notches in there? Is it around a support in bearing? So there's a lot more context that I'd need to understand exactly why they're using that, and potentially is it to do with splitting of the beam? So you can really get into the nitty-gritty here, which I think is quite difficult. I think that's quite a very technical question, which I'll definitely suggest. I can share my email and people can always give me or look me up on LinkedIn. You can drop me a message if you've got a more specific question, because I think there's a bit more context that I'd need for that. But essentially, when you start bringing in things like resins, there are obviously additional knock-on effects around fire design. And then the question around that is, what is that element doing? So for example, in connection design and reinforcement, is it needed? Does that connection? So do certain screws need to be protected in the fire case? Because what is it doing in the fire case? So there's a lot of considerations around fire design, especially when you start getting into connections outside of just the standard section size that you'd be looking at. So no, that's an interesting question. I'm interested to know in what context they're reinforcing the beams, to be honest. So I don't think I could go too much more in that in this instance.
No, that's fine. And I think someone was asking a question about if you could talk a little bit more about the use of mass timber and also kind of concrete, in particular composite concrete as well, and those particular connections.
Yeah, certainly. So why would someone look to use a composite slab is always sort of the first question, and usually it's to essentially enhance the stiffness of the CLT. One thing with timber is it's a pretty stiff element, but especially when you think of a solid timber element and you think of vibration design. So if you think of a solid timber table, if you knock on that table, it vibrates, you can hear it. So acoustically, it's vibrating, and that's the same when you talk about vibration in a space for how you experience. If someone walks behind your desk right now, because they're walking, does it cause your table to shake and your computer screen to shake? Ideally not, because someone's considered the stiffness of the floor system and the structural system so that the building's stiff enough to not allow that to happen, and you design for that. And that's a lot of the time, that's where the composite comes in, because it can add a lot of damping. It can really help with the vibration side, as well as giving you some composite action for when you think of beam design, of tension edge and compression edge, and how you can utilize concrete and timber together between the compression capacity of the concrete with the tension capacity of the timber, and how that can actually enhance the performance of a floor system and potentially reduce either the structural depth or just to achieve a higher stiffness, especially when you think of buildings which require a screed as well anyway. So it can really double up on a few elements at the same time. We don't see too much of it in the UK at the moment. It is coming through. A lot of it is, you see a lot more in Europe. They're always pushing different boundaries a little bit more. And I think just the way that typically their on-site trades work, it kind of works with sequencing and just again, how their on-site practices allow them. Because again, you're bringing in a wet trade. Well, potentially not, but typically it's a wet trade coming in after a dry trade. So you've got timber, you're doing a lovely dry timber building, bringing in a wet trade to come in and apply all that concrete. There are now some people are looking at prefabricated systems, so doing the concrete in the factory or the warehouse with that. And again, it really depends on what's the rationale for it. Is it a structural side, vibration side, so more of an SLS of serviceability design requirement, where it's coming from. But it does have a lot of different benefits, but you really need to weigh up, is it worth it? Is it needed? What's the knock-on effect as well, because of whether it's cost or installation and sequencing of these elements within either manufacture or installation. Connection side's really quite interesting with them. You're essentially creating shear keys between the CLT, the timber deck, and the concrete. So essentially you're routing out sections of the timber and potentially putting fully threaded screws in. Shear key where it gets bonded to. Very similar to the concept of if you're connecting a concrete slab to a concrete column and you leave the rebar exposed at the top, so you can make that connection between a column and a raft. You're doing a similar thing, just using screws into the slab so that the concrete can bind to that, and then you're utilising the shear capacity between those. So yeah, there's quite a lot you can get into with composite. It just really depends what's the rationale for wanting to use it, what's the design consideration that you're looking at, really.
Okay, brilliant. And then just the final technical question that we've got. So they were talking about the codes and that it doesn't include the use of flitch glulam. They were saying, is there any particular reason why this hasn't been done and why that's not in the codes?
Dropping out. Can you
yeah,
still hear
you're
me?
back. Yeah, you're back.
Perfect. I've got a spinning wheel. I was worried. So the main thing with the current codes, I believe EC5, Eurocode 5 for timber design, I think that dates back to 1995. Obviously, there's been national annexes and things that come through up to like around 2014, and there's always things that come through to update them. The next update, I think, was meant to be released at least 4 years ago. I think it was originally due out 2020. So the next version of Eurocode 5 is expected over the next couple of years. And as I understand it, I believe they are looking at including flitch beams. Now, the main reason why was it not included before, because when you're talking about flitch beam, especially for context, if anyone's not aware, or just for extra context to what we're talking about, you're talking about two timber elements with a steel plate in between. Typically, when you're talking about flitch beams, so you're utilising the timber and the steel. Now, when you're designing these, you're not actually designing. Typically, you're not designing a composite element. It's all about load distribution between the two. So therefore, when you're then designing the steel element, you're designing that to steel codes. So you're not designing. So it's kind of it's a grey area crossover, which is why it's traditionally or currently isn't included in the code, but it's something that they're looking to include. So at the time, widely used, you see them a lot. You can even buy them as almost standard products. There are certain people out there, probably more in Europe or even continental America, USA, sort of in the United States and North America. They
I think Josh will come back in just a second. He's talking about continental Europe and I think South America there. think it's going to coming back
Yeah.
now. Yep. Sorry, Josh. We had you at Continental Europe.
Yeah, so essentially they're probably more widely used on the continent in certain places or North America. But again, it's kind of that fundamental reason I think on the design, on this, how you actually design a flitch beam, whether it actually needed to be incorporated in the codes. But as I understand it, they are looking at including a chapter in the next version of Eurocode 5 to cover flitch beams. So it is coming. And yeah, it's just understanding how you design them really and whether they need to be. So you can definitely design them without, it's just understanding what you're designing. And you're not actually designing something composite. So there's ways around it. And it's you picking and choosing the codes as you need them to design the individual elements of essentially a component.
Awesome, mate. Awesome. I just didn't think about that. If there's a steel element in the middle, like which code it would actually go to. So that's quite interesting that there's probably still a lot to be done when it comes to merging the two materials together and which code it goes to as well. Okay, interesting. So just leading on to just the wider context then. So what can everyone do? Because I know a lot of people are so passionate about the use of mass timber, and sometimes, you know, whether it be from a client perspective or maybe it just not being pushed enough in the office, like what can people do to promote the use of larger scale, more complex timber projects?
So I think, I mean, number one for me is understanding. So understand the material. If you think you want to use it, do some research, reach out to companies like ourselves, Urban, there's other people in the market, Strada, TD UK, so Timber Design UK. There are webinars available. There are CPDs available from people. We ourselves, we do offer CPDs, typically online at the moment, but we can offer them and really get that understanding of why would you specify it. Because obviously it's the market we're in. We're all in this. Pretty much everyone in our office is driven by timber. Everyone came here because of the want to work with timber, whether it's from a sustainability side, architectural side, because you can expose it, and biophilic design, etc. We have a lot of architects in our office who are project managers. So there's a lot of reasons why you'd want to use and work with timber. But the main thing is to understand, okay, why do you want to use it? And really build that knowledge, because once you have that knowledge, you can help that with your design team, and then you can express that with the client especially. And a lot of times getting client buy-in, and it's understanding why is it beneficial. I was recently at the Timber Design UK at their inaugural timber conference in London earlier this year. And I attended that, and it was really quite interesting because they had a couple of insurance brokers, commercial developers. There's been quite a few commercial projects in the UK, especially in London, where they're either new commercial buildings or they're building additional stories onto existing. And by doing that, they're looking at using hybrid structures or timber or solid timber and mass timber structures because it's a lighter element. Timber is typically a fifth the weight of concrete. So immediately, if you're trying to build up above on top of an existing, you want the lightest frame possible because you're trying to utilize existing foundations and structure below. So it was really interesting hearing someone who's actually on the developer side. So they weren't in the design, they were essentially the specifiers and why they were looking at it. And there was at least 2 or 3 there who spoke, and they mentioned something to do with the cost, and they found that mass timber options were coming in around 3 to 5% more expensive than maybe a steel frame. Now this is on commercial projects. And I found that was really quite interesting because a lot of the time you get that question, is it cost comparable? Is it competitive? And that gap is closing 3 to 5%. So if you compare that, that could be on a large project, a large part of a budget. But at the same time, what is the rationale for wanting to use timber? So is it because of the sustainability side, because you're wanting to use a green solution and you want to trap in carbon, you want to make a positive impact in the world with the buildings that we're designing and within our industry? And if it is 3 to 5% that higher cost for pushing it that way. And the more that we do design with it, that cost will close down. And I think
Oh, I think we've just lost Josh and his flow there.
Okay, I
He's
think I'm
coming
back.
back. Yeah, back. Sorry,
Yeah,
carry on.
only apologise.
No
Yeah,
worries.
no. I think no. For me, it's considering. It's not just considering why would you use timber. It's also the question why are you using steel or concrete or any other material. What's the rationale for any material you're using? Are you using one just because it's a norm? Are you using one because whether it's cost, is it because of efficiency, is it just because how things have always been done? It's not always analysing what's the new option that you want to look at. It's also analysing, well, what's the current option you're using and why, and then actually weighing them up together. And I think when people start to do that, you start to understand the potential benefits or potential reasons for using and specifying mass timber and timber solutions. Because I think it really starts to come into its own when you start to account for that. And I think the key thing here is, obviously I'd love a full mass timber solution, but it has to work with an architectural design as well. We have to utilise steel, whether it's beams, columns, you still need a concrete foundation. So every material has its place. And it's just considering your design, where's the appropriate place to use timber. Because you also don't want to be putting excess timber into a project, because as much as you're storing carbon in that one building, some of that could have been used somewhere else, and we're still extracting others. So there's a lot of different ways you can look at it, and there's pros and cons to every material, and it's just really assessing them all and trying to bring it together.
Cool. So just before we sign off, Josh, I'm just going to experiment by switching off my camera and mic to see if that gives you enough streaming power to share the projects. So if it does, great. If not, we might have to sign off. But what I'll do is I'll just switch off my camera and mic, and let's give it a try. See what happens.
Okay. Right, perfect. Thanks, Don. Right, we're into the world of the unknown. I'd just like to apologise to everyone for my connection today. We've recently moved into a new floor on the office with new meeting rooms, and I've given them a go. And apparently the connection that I've been using hasn't been perfect. So let's just try share this screen. So I think we're working. Okay. Don, please step in if this stops working at any point. So, as I mentioned before, we operate on a few different sectors throughout the industry, whether it's commercial, education, residential, and sort of everything in between. So what we showed earlier was the Cascades project, which was this one here, which is in Cardiff, 7-storey, multi-storey residential. It's something that we're still trying to develop post-grant for and understanding materials. Now, moving on to another, so as I mentioned then, we talked about some long span beams. So here's a demonstration of this. So a sports hall. I'm hoping I'm still sharing, so I'm just going to flick back to test. I believe I am. So this is a sports hall. So these beams, this is for it's called Wellness Centre. It's in East London, out towards Epping Forest. These beams are circa 1.6 metres deep. They're 24 metres long. The span of the beam actually goes past this wall here and to the external wall on the side. That's a viewing gallery. This is to be a basketball court, in line with Sports England design requirements for basketball court and tennis courts going the opposite way. These beams are around 1.6 metres. As you can see, these are solid glulam elements. These have then been pre-cambered as well to account for any dead load deflection. So that can also be accounted for within glulam to aid with the SLS design. And this is what you can within mass timber as solid elements without even going towards truss systems. Of course, architecturally, maybe a truss system could be beneficial and you could utilise a truss in this scenario too. This was the architectural intent which we're looking at achieving. This is another area of the same building. So again, what you can see here is this is a first floor. It's still 3 to 4 metres tall. You've still got a 24 metre length beam. And in areas we're utilising mid supports as CLT walls, as well as central steel columns. So again, steel's been introduced because of it being able to be a lower profile, so it could fit within a partition wall that will be going in at a later date. I believe this building is either complete or due for completion over the next few months. We completed on this back in the summer last year, so it's been going on to fit out since. Space and dance studio area, and you can already see the use of timber and sort of the lightness of it, even though the water all boarded out. What you can see on the floor here is we use a membrane pre-applied at factory on all floor slabs to do moisture protection. That gets pre-applied at the factory, which is definitely critical on visual projects to avoid moisture staining during the build. And it's a temporary protection where the membrane stays on for the life of the project, but it's there for the temporary during the build, so that we can manage the moisture and the water. So for example, from rain that could pool on the slab, we can manage that throughout the build. And essentially we then put in a moisture management plan to ensure that that water is being brushed off the timber structure in appropriate locations. And then on top of that, we monitor the moisture content of the timber throughout the build. So that's both visual inspections, so understanding where you can visually see, and our experience of understanding where that's an issue, where that's high ingress, where that's low, through to actually taking hammer probes and moisture probes to take moisture readings. Timber typically comes out of the factory around 10 to 12% moisture content. For linings to be applied to timber, you want that moisture content to stay below 17. During winter, it will naturally, through equilibrium, due to temperature and humidity, go up to around 15, 16%. So you will get close to that 17, even if it hasn't rained, potentially, during winter. During summer, it can dry out to about 8% if it's in direct sunlight. So there's a lot of variety in timber moisture, and it will change throughout its lifetime. Timber will shrink, it will grow, it'll absorb moisture, and it will find an equilibrium as a hygroscopic material. So it's all about understanding the material and then how we detail and design that from our side, manage moisture on site. So that's just a little bit of a crash course conversation on that there. So if you have any question on that, again, you can drop me a message, drop Dom a message for engineers with ideas, and we're happy to elaborate where people are interested or have questions. And again, yeah, you can just create these interesting spaces with timber design. I've got a feeling I can hear Dom in the background. Does that mean I disappeared for a bit?
No, you're absolutely fine. Absolutely fine.
Oh, brilliant, it worked.
Perfect. Yeah, that worked absolutely perfectly. Was there any more images to show, Josh? I think that was.
I mean, there's always a few. It depends what people are interested. I think in terms of just scope, I find this one really interesting. This is a project which we've just completed on, and this is a school project. And so again, the use of timber in education, so biophilic design. But what this is interesting is a staircase. So the use of mass timber in a staircase. The actual stair element here is solid timber. There's no steel here. It's made up of 5 elements. The balustrade is 1 fabricated piece. And then there are 3, the flight, the half landing, and the flight is an element. And it's got cantilevering half landings at the top and bottom for the slab to stand in. And then I think there's a picture. So again, the use of mass timber in a local area. Here we go. And so the staircase there, showing the atrium space. And here we go. And then how you can utilize mass timber for feature staircases as well, and how timber engineering can be quite flexible, and you can do quite bespoke designs, and how understanding the material enables you, and not just the material, but understanding the fabrication processes and limitations, you're able to design and build elements like this. And actually we can fabricate solid CLT stairs, so an entire flight can just be one element which gets craned into place. So that is one solid element where the treads were actually routed out of a solid timber panel. And then it gets fabricated on the ground together, made up on the ground, and then it can be lifted as well. And that's probably where there's always more I can show, but I think for now I'll probably leave.
If there's one more or a couple more you can show,
yeah,
they
sure.
were quite interesting. Let's just keep it rolling. We don't really need to worry about going over time
too
much. But yeah, just show a couple
That's,
more. That'd be great.
The internet seems to be working. So I'll close that folder. I suppose on the opposite end of the spectrum, private houses. We've done a few. The island of Jersey. So out in the Channel Islands, so off the coast of North France. So again, private residential houses. This is obviously quite a bespoke, high-end house. This was using a French CLT supplier, so it wasn't using spruce. This was using pine. So again, different suppliers may use different timber species within, and you'll get a different visual quality or and a different feel. So this is a lot more orangey and a deeper colour than what you'll see in a lot of the UK supplied CLT. And again, using timber design in different scenarios, how you can cantilever them out to create different details, whether it's just for an architectural detail, where they're trying to create a little terrace and a light well through. So utilising the CLT as deep beams, so not just as a panel beam element. Through utilise that with our
So we have just lost you there, Josh. So may have to be just the last few slides, this one.
No problem. Probably a bit too quick. So yeah, so we can do everything from private residential all the way through, and mass timber can have its place in creating different architecture, but also different structural solutions. I'll probably leave it there then, just in case.
Awesome. Well, Josh, that goes without saying. You've been an incredible guest. Thank you very much for breaking everything down so simply, so understandably as well. I think it's on a lot of people's minds at the moment, and just hearing from someone like yourself and just explaining everything in depth like that, I know a lot of people will have learned a lot from this session. So just goes without saying, thank you so much for being a guest. And yeah, of course, please watch out. I know it's been in the chats, but we do have our live event coming up, which is going to be Wednesday, the 18th of September, which will be at the offices in Shoreditch with Web Yates engineers, where that will be a panel discussion with myself, talking about everything related to support for chartership. So, Josh, thank you so much. It's been an absolute pleasure to have you on. Yeah, and we've got over the technical difficulties, and we got there.
No, thank you very much for inviting me. Apologies for the technical difficulties. If ever again, I'll ensure that it's a plugged connection and we don't have that issue. So apologies for anyone listening, and yeah, thanks for having me on. And if anyone does have any questions, please reach out. You know LinkedIn, you can find me. I work for Urban Limited, so yeah, please reach out.
Awesome. All right, Josh, thanks very much.
No problem.